Good afternoon all. I am Viresh Patel. I am presenting the paper number 43, which is titled as Locating Faulty Section in the Tie Line Using Classification Based Method. Motivation behind the paper is to detect the faulty section on the tie line, utilizing the wide area data for faulty section detection, reducing the outage time by reducing the search time for the faulty section, improving the reliability index by reducing the overall outage timing. Research background for the idea is as given below. Locating faults on the tie line are based on traveling wave, fault impedance, and machine learning. Traveling wave is accurate, but it will inject the unwanted harmonics into the system, whereas fault impedance based methods are simple, fast, but inaccurate. Machine learning based methods are most recent, are mainly based on regression based learning, whereas here in this paper we have used classification based learning. Formulation and method used here. The faulty section identification is formulated as classification based problem. Three stages to formulate and solve the classification based problem. First is to collect the data and tag the data accordingly. Utilize this tag data for training classifier models. Then test and validate the trained model. Classification method used to solve classification problem here are linear discriminator analysis (LDA) and support vector machine (SVM). LDA can perform the multi-class classification in a one go or easily, whereas SVM is a binary classifier, hence it will need some strategy to handle the multi-class classification. Therefore, we use one versus all strategy to handle the multi-class classification system and the data used for the verification of the method. Contour 2 area network is used for the verification of the method. Here, Contour 2 area network has a two tie lines which are divided into three equal sections as shown in the figure. Different short circuit faults are simulated with the different loading condition, and all the acceleration power of the generator are collected as an input feature, and output will be fault in which section the fault has occurred. So you can see from the figure that for acceleration power directly is depending on the fault in which the section fault where the fault has occurred in section 1 or section 2 or section 3. This acceleration power data is then tagged with the faulty section number as shown in the table below. Data with the fault in section 1 is labeled as C1. Data with fault in section 2 is labeled as C2, whereas data with fault in section 3 is labeled as C3. Here, faulty section is located using two methods, which is LDA and SVM. LDA utilizes acceleration power from all the generators, whereas SVM uses acceleration power of generator 1 and 3 only. Results from the SVM method are presented in the figure below. One figure on the left-hand side shows the RBF kernel, whereas on the figure on the left-hand side shows the linear kernel function results. You can see from the figure itself that RBF kernel function performs more accurately, whereas linear function performs less accurately. Now comparing the results from LDA and SVM based methods, the results can be shown as shown in the table below. From the table we can see that time for training of LDA with linear function is lesser as compared to SVM with RBF kernel, and time for prediction is also less as compared to SVM with RBF kernel, and in the accuracy of the LDA is lesser as compared to SVM with RBF kernel. Now we can conclude that Problem of locating faulty section in the tie line is formulated as classification problem, which is less complex and less time consuming. LDA and SVM method are compared considering the crucial aspect of the implementation that are time consumed for training and prediction, accuracy of the prediction, design complexity involved. It can be concluded from the result that SVM is slow as compared to LDA, whereas accuracy achieved in SVM is much more higher than LDA. So we can use LDA where the time is critical and SVM where accuracy is critical. Now here I want to acknowledge the USS project, which is funded by Department of Science and Technology and Indo-US Science and Technology Forum, which supports the work over here in this paper. Thank you.